looking at 3.2, 3.3, which is properties of parallel lines and proving that lines are parallel. You'll notice we hopefully have some familiar vocab here, right? With our angle relationships, corresponding angles, alternate interior angles, and same side interior angles. I believe we defined those on Monday, yes? Okay, excellent, good. But today we're going to talk about them in terms of postulates and theorems, which means these are going to be things that we can use in our proof writing, or we can possibly write a proof about them. So first thing is the corresponding angles postulate. So quick refresher for our angles here, just to make sure we remember what they look like. Remember, you might have your two lines. Maybe they're parallel, maybe they're not. They're cut by a transversal, right? So this is like a very basic diagram of what our angle relationships might look like. Corresponding angles are going to be ones along the same side of the transversal and either both above or below or same side of the transversal and then same side of the lines that are being intersected. So for example, this angle and this angle would be an example of corresponding angles. Okay. Our postulate with this is that if two lines are cut by a transversal, then corresponding angles are congruent. So if we have two parallel lines, those lines are being cut by a transversal, then that angle relationship is going to form congruent angles. You'll notice this one is a postulate. That means it is accepted as true without proof. And you'll notice the rest are theorems. We actually use this postulate to prove the remainder of our theorems at some point. So really the important thing you need to realize here is if you have these parallel lines and this angle relationship is going to be congruent. Alternate interior angles. Oh, as I erased the other half of my picture. So alternate interior angles would be on opposite sides of the transversal between the two lines. So maybe something like where I put angle 1 and angle 2 here. And this theorem is very similar. If two parallel lines are cut by a transversal, then alternate interior angles are also then congruent. Same side interior angle theorem. If parallel lines are cut by a transversal, then same side interior angles are supplementary. This is really, oh, what happened there? This is really the only one where they are supplementary. And if you kind of take a look at this picture here, remember same side interior angles would be like there. If you look at a picture like this, again, this is a very basic one. Not the most beautiful thing you've ever seen, but it'll do. Aren't these basically a bunch of acute and then obtuse angles? And you'll notice it's always going to be the two that look like they're acute. Those are the ones that are congruent. The two that look like they're obtuse, those would be congruent. But if you're dealing with same side interiors, doesn't one look obtuse and two look acute? There's no way those could be congruent unless they end up being right angles, right? But in this situation, they're not going to be congruent. They're going to be supplementary, right? So just a kind of a little quick way to think about it. Mind you, that only applies if the lines are parallel. If they're supplementary, what's that mean? Ashley? They're going to have a sum of 180 degrees. Okay, good. And then the perpendicular transversal theorem. This says if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other one also. Kind of similar to the theorem, the always, sometimes, nevers we talked about a bit today. So what this is saying is you're going to have two parallel lines and you have a transversal intersecting them, right? It is saying if this transversal is perpendicular to one line, then it is going to have to also be perpendicular to the other line. And that's because those two lines end up being parallel. So that's why that works out the way it does. All right. The next thing we are going to do here, well, first of all, I guess, is there any question about our vocab so far? No? All right. We are going to actually now use the corresponding angle postulate to prove the alternate interior angle theorem. Right, because again, a postulate is accepted as true without proof, but a theorem we can explain and justify. So this says that we are given that line K is parallel to line N, and transversal T cuts lines K and N. Prove angle 1 is congruent to angle 2. Did we discuss last time? I don't think we did, because we didn't talk about any parallel lines. Did we talk? I'm starting parallel lines with my other geometry class at the same time, so I can't remember which we talked about versus which my regular geometry class we talked about. Have we talked about how to label parallel lines yet? Like that you use the two little lines as the parallel symbol? We did talk about that. Okay. Did we talk about that in order to mark in a picture that lines are parallel, you put little, except these are really ugly, you put little arrows in them, like this? Did we discuss that? Okay. So if you see any labeling like in your book, if you have that open, or if you have it open on your computer on page 79, there's little arrows on your lines, little red arrows. Those are there to indicate that those lines are parallel. So 1 on each indicates they're parallel, 2 on each indicates they're parallel, etc. So what we are going to do now is just prove this. So first thing is always your what? What's always your first step in a proof? Logan? To state the given. Good. So let's state the given. Line K is parallel to line N. And I'm not going to write out transversal. I'm just going to put T cuts K and N. Lucas, did I give you a copy of the notes? You just like taking notebook ones? Okay, that's fine. I just didn't, I was worried I forgot about you or something. Okay, I just changed colors. That's okay. All right, this is your given. We are going to prove that angle 1 is congruent to angle 2. Now, this is a theorem, right? So we can't quite use it yet. You'll be able to use it after this. But we do have a postulate, and our postulate is the corresponding angles postulate. So we want to potentially use that postulate to prove that angles 1 and 2 are congruent. And a lot of this then ends up happening using the transitive property. So if you take a look at your picture, we need to figure out a way to connect angle 1 to angle 2 using information from our postulate. Well, if you look at angle 2, is it a corresponding angle with another angle in your picture? With which one? 3. Angles 2 and 3 are going to be corresponding angles, right? And we have parallel lines. So if we have parallel lines and we have corresponding angles, what are we going to be able to say about angles 2 and 3? If you need to, you can look up at your postulate up above. They're congruent. Yeah, someone at home said it. They are congruent. Exactly. So what we're going to do now is say that angle 2, but hopefully not in highlighter. We are going to say that angle 2 is congruent to angle 3. Now, the reason we can say that is we had parallel lines, right? They were cut by a transversal, so our corresponding angles were congruent. That is the corresponding angles postulate. And remember, if you ever don't remember a name of it, is it okay to write out an if-then statement? That's totally fine. So corresponding angles postulate. Okay. So now we've talked about angle 2. We've introduced angle 2 into our proof. I still need to introduce angle 1 into our proof though, right? Because that's part of my prove. I have to say something about angle 1. If you take a look at your picture, is there anything you think you could say about angle 1? That's a property or a relationship we already know, Ashley? Angle 1 and 3 are vertical angles. And if these are vertical angles, what can we conclude about them? Nick? Yeah, they are congruent to each other, right? That is our vertical angle theorem. So we can now do that with angle 1 and 3. So angle 1 is going to be congruent to angle 3. That is the vertical angle theorem. Okay. Now, where could you think we could go from here? We have that angle 2 is congruent to 3, 1 is congruent to 3. Lucas? Absolutely. Yeah, we can now conclude that angle 1 and 2 are also congruent. Good. So angle 1 is congruent to angle 2. Anyone remember what property lets you do that? This one, so technically if they were equal signs, we could use the substitution property. But what's the one that so substitution property that can't be used with statements of congruency. So does anyone remember what we would use instead? Peyton? Transitive property, yes, which is very similar. They're almost always interchangeable except when it's congruent. So transitive property. Does that make sense? Okay. And now we just prove that theorem. Okay. Some of them, I think proving a lot of the other ones is part of your homework, but you're kind of going to follow the same process. It ends up being a lot of transitive property normally. Show me what angles are congruent, figure out a way to connect the ones you want. All right, good. The next proof, this one is not proving one of our theorems. It's just a general proof. We're going to practice kind of tying some angles together here. We have that angle 1 is congruent to angle 2, and line L is parallel to line M. We are going to prove that angle 1 is supplementary to angle 3. So let's just plan out our proof first before we start. We have that angle 1 is congruent to angle 2. I would mark that. And angle 1 is supplementary to angle 3. Now, if angle 1 and 3 are supplementary, or no, that's what we're trying to prove, I'm sorry. We have that 1 and 2 are congruent and that L is parallel to M. So these lines are parallel. We are going to prove that 1 and 3 are supplementary. So somehow we're going to need to introduce angle 3 into our proof and figure out a way to tie it to angle 1. Now, we were already given one set of congruent angles, right? 1 and 2. Those are alternate interior angles. Those are provided to us. But what was the point of it telling us that lines L and M are parallel? What would maybe be the point behind that? If you look up above at your theorems, why is that maybe helpful, Logan? Right, it's going to give us some angle relationships, basically, right? So it's either if you are provided with a set of parallel lines, it wants you to see, okay, well, if these lines are parallel, do I have congruent corresponding angles? Do I have congruent alternate interior angles? Do I have supplementary same side interior angles? Now, if you look at angle 3, does it have an angle relationship with another angle in this picture? Ashley? Yeah, angles 2 and 3 are same side interior. Now, why might that be helpful if we're trying to prove that angles are supplementary? Ashley? Okay, 1 and 2 are congruent, yes. And if 2 and 3 are same side interior angles, they're going to be what? Supplementary. So 2 and 3, we're going to be able to state that 2 and 3 are supplementary. We know 1 and 2 are congruent, so will we be able to maybe do some substitution, set up an equation, do some substitution, and eventually prove 1 and 3 are supplementary? Does that kind of make sense? Does that sound like a good plan? Okay. And depending on which angles are labeled for you, there might be more than one good way to do a proof like this. This is just the path that this particular picture is leading us down. So we're going to say angle 1 is congruent to angle 2, and line L is parallel to line M. That is given. So we have a set of congruent angles, so that's great. We can't really use that yet, but we do have parallel lines, and we just learned a bunch of theorems and properties, or theorems and postulates about our parallel lines. So if line L is parallel to line M, Ashley told us we could say what? What was our angle relationship that Ashley told us about? Logan? Well, we already have that, and we will use that. But how could I use L and M? Which angles are attached to lines L and M? If you look at L and M, which two angles are attached to that, Ben? 2 and 3, right? And if you look, because angle 2 here is attached to line L with P as the transversal, right? And angle 3 is attached to line M here with P as the transversal. And angle 3 is in our proof, so we need to introduce it into our proof in some way. So we are going to introduce angle 3 into our proof by saying that angles 2 and 3 are supplementary because they're what kind of angles? Ashley? Same side interior angle. So we are going to go ahead and say that angle 2 and angle 3 are supplementary. And we can say that, you go up to your theorems up above, if two parallel lines are cut by a transversal, then same side interior angles are supplementary. That is our same side interior angle theorem. And I am doing some abbreviating. That's okay if you do too. Up to you completely. All right. So I now have all my angles I need introduced to my proof, but now I got to work towards getting 1 and 3 connected to each other. Well, now, do I now have a vocab word in my proof? How could that maybe be helpful? Peyton? Very good, because then I'll now have an equation, and then I can finally maybe do some substitution, right? So yeah, we're going to use our vocab word. We have that these two angles are supplementary, so we will use that and say the measure of angle 2 plus the measure of angle 3 equals 180. This was a common mistake on your chapter 2 quiz. What lets you do that? What lets you say that if angles are supplementary, then they have a sum of 180? Logan? That is the definition of supplementary angles. A lot of people said angle addition postulate on your quiz, which would not necessarily work if you were given supplementary angles, right? I guess it kind of depends on your image, but that's technically, because you're given supplementary angles, they add to be 180. That is the definition of supplementary angles. Good. All right, now we have an equation. We have that the measure of angle 2 plus the measure of angle 3 equals 180. Where do you think I could go next? But be careful because there's a notation issue. Logan? Yes, the definition of congruent angles. Yep, yeah, but very good, yeah. This is not quite ready to be substituted in yet, right? Because isn't this a congruency statement? And this is an equation, so we got to fix this up first. We're going to say first that the measure of angle 1 equals the measure of angle 2. That is the definition of congruent angles. Good. Now is it ready to be substituted in? Absolutely. What we are going to do now is we are going to take the measure of angle 1 and we are going to replace it with the measure of angle 2 because we want to be able to say that 1 and 3 are supplementary. Good. So the measure of angle 1 plus the measure of angle 3 equals 180. That is the substitution property. So remember, with the substitution versus the transitive property, this is you're actually taking a value and plugging it into an equation that already exists, right? So that's why this one is substitution and not transitive. And then we've now shown that they add to be 180. Are you basically done? What's the last thing I need to say? Ashley? Very good. Angle 1 is supplementary to angle 3, and that is the definition of supplementary angles. Very good. Good. That's a very standard type of proof that you'll see with these, right? You're either going to see ones that are like figure out a way to use the transitive property to tie angles together, or if things are supplementary, you might need to substitute in some values and things like that. Any questions about those? No? Okay. All right. Couple examples here. This first one, I've given us a pretty basic picture to start with. And then if you look at the back, we got a little bit more of a complicated picture going on. So for this first example, it says if the measure of angle 1 equals 130, find the measure of the other numbered angles. So we are given that the measure of angle 1 is 130. Now, take a look at your picture. We have two parallel lines. Which lines are parallel? Lucas? L and P, because they have the little arrows, right? T and K, we don't know if they're parallel or not because it's not marked. So what you want to do in a situation like this is we actually have more information than we really need for this problem. You can kind of ignore line K here. And pretty much, guys, if you have two parallel lines and there's just one nice, pretty transversal going through them, everything is either congruent or supplementary. So I would just take a quick second, see which ones you can figure out, and then we'll check them, and then we will move on from there. So take a second, figure out what all your measures are. All right. Did you guys just try out 1 or did you try out 2 and 3 as well? Which one's Logan? Oh, you did all of them. Okay, that's why it took us a while. You didn't have to, but okay, good. Did we all try out all 3 of them? Oh, okay. Well, a little mixed, that's okay. All right, we're gonna go over all of them anyway. So number 1, if the measure of angle 1 equals 30, find the measure of the other numbered angles. Ashley, what'd you say for the measure of angle 2? All right, absolutely. The measure of angle 2 would be 50. That's a linear pair, right? Just subtract, those would be supplementary. Ben, what'd you say for angle 3? For angle 3. So right here, if you take a look, aren't 2 and 3 vertical angles? So 50, yep. Angle 3 would be 50. Lucas, what'd you say for angle 4? 130, absolutely. Okay, let's pick on some people from home. Adrian, what did you say for angle 5? Absolutely, that would be 130. Adrian, I think this is the first time we've actually spoken. It's very exciting for me. All right. Angle 6. Ben V. Ben at home, what did you say? Absolutely, that would be 50. Oh, this is an easy way for me to hear from some people at home. That is 50. Angle 7. Brock S, what did you say? 50, absolutely. And then last one. Caleb B, what did you say for angle 8? 130, good. All right, that was pretty easy, right? They're all either 50 or 130. So now moving on then to 2 and 3. In this situation, it says that the measure of angle 6 is 6x minus 5. So 6 is 6x minus 5. And angle 4 is 13x minus 5. With something like this, you need to determine the angle relationship and then figure out an appropriate equation to set up. So what angle relationship would 4 and 6 have? Sydney? Yes, these would be same side interior angles, which makes them supplementary. So what would be an appropriate equation to write for these? Nick? Very good. Add them up, set them equal to 180. 6x plus 5 plus 13x minus 5 equals 180. Good. Combine my like terms next, right? What do you get when you combine your like terms, Lucas? Oh yeah, I copied this wrong. Made a negative sign there. Thank you. There we go. Okay. Yep, that would be 19x minus 10 equals 180. Add your 10 over, 19x equals 190. Divide that out, you should get 10. If it had asked you for the measures of the other angles, make sure you plug it back in. Okay, it's an easy like little thing to forget about. Okay. And then for number 3, this is why it was taking us a while. I forgot I put a factoring problem on the homework. Excellent. So for number 5, or for number 3, angle 5 is x squared plus 11x, and angle 1 is 2x plus 70. What angle relationship do these have, and therefore are they congruent or supplementary? What do we think? Logan? They are corresponding, so therefore would they be congruent or supplementary? Congruent, very good. And if they're congruent, how could we set up an equation for these? Peyton? X squared plus 11x equals 2x plus 70. Good. All right. This is good practice for us. We got to know how to do this. So there's a squared in it, right? This makes it a quadratic, which means if you cannot get the x squared all by itself, right? Like where maybe the regular x terms would cancel, or if you didn't have regular x terms, sometimes you can solve by taking square roots. This one you cannot because you have x squared terms, you have x terms, and you have constants. What do we need to do to get this in a form that we could solve? Any ideas, Nick? Very good. We got to get this set equal to 0. So what should I move over and how would I fix it, Nick? How should I write it? Yeah, I want you to tell me what I need to reorganize, however you want to say it. I'm not picky. Yeah, absolutely. We would subtract it over, and when you subtracted it over, Nick, what did that become? Yep, good. X squared plus 9x minus 70 equals 0. Excellent. Now, you would need to, yes, Sydney, or are you just like, your hand just here? Okay, you're just like, please stop doing proofs. Is that what like this is? Okay, or not proofs, but factoring. So, for this one now, we need to then decide, is it factorable? Is it not factorable? I would always probably just try to factor it first. The quadratic formula takes like 100 years to do. It's not my first recommendation. So, but if you ever need it, it's right there. So, just a heads up. Anyway, so next step with your factoring is I would get this into 2 sets of parentheses. And this one is not a difficult one to do a little bit of guessing and checking with because there's no a term in the front, right? It's just an x squared. I do have some like little shortcuts of ways you can do ones with like a term in the front. So if you need help with those, let me know. But you're basically looking for numbers that multiply to be 70 and add or subtract to be 9. I like to start by just putting my x's in either set of parentheses, right? And then think about your numbers. What are maybe some numbers that could multiply to be 70 and add or subtract to be 9? Logan? Five and 14. Yeah, sorry, I had to do that multiplication in my head real quick. Yes, 5 and 14. Is it? I was thinking 14 and 5. Now I'm second guessing my mental math. You said 14 and 5. Yeah, that'll work. For some reason I had, in my head I was saying 5 and 14, and for some reason that was different than 14 and 5 because it's the end of a very long day for me. So yes, so what I do next, guys, this is just like a little trick that I have from teaching, trust me, many people how to factor who are not great at factoring. You guys are pretty good at factoring from what I've seen so far, but just a little trick. I put my numbers in first. I know some teachers teach you to like put your signs in first. Did you no? I've had some students that are like, I always put my signs in first. Don't do that. Do that last. Okay, pick your numbers. Why does my pen keep having a connection today? Okay, 15 and 4. Okay. Then I like to pick my signs next because now you know it needs to multiply to be a negative, and now you can physically look at the numbers written, 15 and 4, and decide how you can make a positive 9 out of them. So what signs do you guys think we would want here? Logan? Thank you. I did it again, didn't I? Yeah. Okay, it's Thursday. And then maybe I can sleep some this weekend. Yes, Sydney, it's only Thursday. Oh no, I'm so sorry. It's not Friday. But as you can see from the numbers I've written down, my brain thinks it's Friday. 14 and 5, is that right, Logan? Thank you. Occasionally I'm gonna write down dumb numbers, just tell me, especially like fourth block, end of the day. My brain sometimes is a little fried. So now that we have the right numbers written down, what signs do you think we would need to make a positive 9 when you add or subtract, and then a negative 70? Yes, Nick? A positive 14 and a negative 5. I agree. 14 minus 5 is 9. 14 times negative 5 is 70. That works. Then what do you do to actually solve it? This is great and all. These aren't our final answers though. Logan? Yeah, very good. You'd set them equal to 0. You end up with x equals negative 14 and x equals 5. Are they both appropriate answers though? I don't know. Let's find out. Because when you plug them back in, they need to be positive. Now, sometimes when you plug in a negative, could it end up being positive at the end? Possibly. So always double check. Don't just assume that because it's negative, it doesn't work. So if you plug negative 14 in here, let's see what happens. Negative 14 squared plus 11 times negative 14, you do get a positive 42. So that is a possible answer. And if you plug in 5, but you then want to make sure that when you plug it into the other one, you get the same answer. So if you did then 2 times negative 14 plus 70, you're also going to get 42. So that is a possible answer in this scenario. Do we understand why? Because when you plug it back in, it becomes positive. Okay. And we didn't have to find the, or if that, well, yeah, so it says to find the measure of that. So I guess we should plug it in. So the measure of angle 1 in one situation would be 42. That's what we get if we plug in that negative 14. And then if you plug in, and then if you plug in 5, we'll put an or. And then if you plug in 5, you're going to have 5 squared plus 11 times 5. And that's going to give you 80 on that side. And then make sure the other side is also 80, which it is, because 2 times 5 plus 70. So then the measure of angle 1 would also potentially be 80. And sometimes that happens. So always double check your negative, right? Don't just assume. I think we saw one. Yes, Peyton, did I do something silly? Okay, thank God. It's like, not again, not 2 in a row. All right. I feel like we saw one in chapter 1 that kind of ended up working out like this, where there was like a positive and a negative. I think it was like towards the beginning of the year. Always double check. If you plug a number in and it is negative, can you have a negative angle measure? No, right? No, that's completely illogical. So always check, because depending on the equation you get, it may or may not work. All right, people at home, any questions? Did we melt your brain with that one? I melted my brain somehow. Sydney's brain is melted. Thank you for admitting it. That's okay. It's okay to have a melted brain sometimes. Last one for this, and then just a couple more postulates, and then I think the end is, yeah, the end is not so bad. All right. Number 4 says determine the angle relationship, but we got an ugly picture. So now this picture, there are several different lines intersecting, yes? We don't necessarily know that any of them are parallel or not. They're not marked as such. So how in the world are we supposed to know which one is the transversal versus the other ones? Well, it's going to depend on which angles it's asking you to look at, because it could change problem by problem. So in number 4, this is saying that angle DGJ, so angle DGJ is right here. And then it's asking you to also look at angle FDE. Where's FDE? FDE. Okay. So that's this angle right here and this angle right here. I highlighted them. I'll put a little like dot there. So this angle and this angle. It makes it a lot easier once you kind of highlight it and you look at it, because if we're just looking at those, does any of that information on the left-hand side even matter? No. So now look at these two angles. We can now look and kind of just decide which lines they're being formed by. Like here you can see line BG, line CE, and then line GF is actually their transversal. That's the line that's going through the other two. Any ideas on what angle relationship this could be? You can use a little process of elimination if you want. Could it possibly be alternate interior angles? Are they even on opposite sides of anything? No, eliminate it, right? Our other options are corresponding or same side interior. Are both of these interior angles? Is angle FDE an interior angle, Peyton? No, because it's so if you look here, angle line BJ and line CE, those are the lines that are being cut by transversal GF. So that's actually on the exterior of those. So the only thing left is corresponding. Now, so these would have to be corresponding. You want a little trick for finding these? Okay, we all know our alphabet, right? I hope so. No, we're not. You know what, it's okay. Some days I'm not sure if I know my alphabet either. There is little tricks to find these by looking for like different shapes. Now, I wouldn't purely rely on these because sometimes the shapes can get a little wonky depending on the picture. But if you're looking for corresponding angles, you should look for like a little F shape. Sometimes it's upside down, backwards, sideways, whatever. But if you look at this, if you squint just hard enough, could this kind of be like a little F shape? You have the right stuff going on. It's like a little lopsided F, maybe a kindergartner wrote it or something. But this could be kind of like an F shape. Logan's like, I don't see it. It's kind of like a wonky F. It's kind of like someone did one of these, right? Someone doesn't know their alphabet as well as we do. But it's kind of that general shape. What'd you say, David? Huh? Oh yeah, it's upside down, it's backwards. It's not a pretty F. This person's learning their alphabet still. But it's just a little trick. You don't have to use it, right? I'm just handing it to you. Do with it what you will. So if you look for like a little F shape, so like same thing, then let's say I had you look at maybe these two angles, maybe angle CGH and BCA. Those would be corresponding angles. You got your weird little F shape. They're both on the left-hand side of BG, and one is above HG and the other is above AC. Just a little trick. Again, do with it what you will. Okay. All right. Oop, except I'm now just drawing all over everything. All right. Oh my gosh. Guys, this like stylus and this laptop and everything. Death of me. Okay. Now we're going to look at angle DGJ. So DGJ, that's this one again. And angle GJH. GJH. That one's right here. Right. So for this one, again, do a little process of elimination. Are these along? So this is being formed by line LF, right? And line KJ, those are your two lines, and then the transversal would be line BG, because isn't that cutting through the other two? Yeah. So are these along the same side? No. Okay, so they're not same side interior. Okay, well, are they on opposite sides of the transversal? Yeah, so what's the only one that we have that's opposite sides of the transversal? Logan? Alternate interior angles. You ready for my little visual trick? You guys might be too literal for it. My regular geometry class really likes the little trick, but your guys' brains might be too literal for it. And if they are, that's okay. But here for angle DGJ, if you kind of like box that corner, and angle GJH, you kind of box that corner. Again, this one's a wonky picture, but if you do it with one that's parallel, it's like a little like Z shape, actually, like a little zigzag type of thing. Again, it's much more easy. It's much easier, much more easy to visualize when it's like the nice picture with the parallel lines and everything. But it again, just a trick to help you find them. Again, this person doesn't know how to write their Z's. That's okay. It's upside down, backwards, and slanted wrong. But that's okay. All right. We're all learning our alphabet still. I feel like I am sometimes. All right, so angle CGH. CGH is right here, and GJH is right here. Okay, now these are being formed by lines LF and line KJ, and your transversal would be line BG. That's what's cutting through both of them. Now in this situation, aren't they both kind of like below your transversal? So they're both on the same side of that transversal. One is above line KJ, one is kind of above line LF. Any ideas for this one, Ashley? Ooh, these ones would actually be corresponding. Because if you take a look, so it would depend. So the ones that would be same side interior, Ashley, would be angle HJG with ACG. It would have to be this one up here. Because if these are our two intersecting lines, LF and KJ, angle CGH is actually not on the interior of those, it's on the exterior of it. Okay, and again, we're gonna look at our trick here. Box it, box it. I mean, don't close it. It's a little bit more of a P this time. Just don't close it all the way and you can kind of get the visual. I do love just watching everyone kind of like tilt in their seat to see if they can figure it out. If your brain is too literal for it, don't use it. You know what I mean? Use the rules instead to find it. It's just a trick. It helps me, but I'm a more visual person. So, all right. So this one would be corresponding. Couple things. I'm not going to like sit here and read through all of these. But what these postulates basically are, you'll notice, aren't they almost written the exact same way as the ones before? Except these are all the converse. Now, what's the point of that? Well, with the previous theorems, we were given parallel lines. We're going to use those to prove angles are congruent or supplementary. This is the other way around. We're going to be given congruent or supplementary angles, which will therefore show us that lines are parallel. So we'll use these to prove lines are parallel. The only things that are kind of new, the converse of the perpendicular transversal theorem, it is basically the converse. It's worded slightly differently to just make it make sense. It says in a plane, two lines perpendicular to the same line are parallel. Okay, so if you have two lines and they are perpendicular to the same line, those two original lines must be parallel. Which is one of those things that if you write it down, it's easy to visualize. The three parallel lines theorem, we actually talked about that at the start of class. Two lines parallel to a third line are parallel to each other. That's like your transitive. So if you have three lines, we'll call this A, B, and C. If I tell you that line A is parallel to line B, and line B is parallel to line C, won't all three have to be parallel? That's what that one's about. And then just two other theorems. They don't really have names, they're more just concepts you need to understand. Through a point, it should say outside, not, oh, it did say outside. I just can't read today. Whew. Through a point outside a line, there is exactly one line parallel to the given line. So if you have a line and a point not on that line, it's saying there is exactly one line that would be parallel. Okay. And then the other one, through a point outside a line, there's exactly one line perpendicular, would just be the same thing, but there's only one that would be perpendicular to it. So the only thing that's different here is you're going to be given congruent or supplementary angles, and you have to use that information to determine what is parallel. So state which segments are parallel, and then state which postulate or theorem justifies your answer. So you want to look for both supplementary and congruent angles. So if you take a look at number 1 here, do you guys notice any congruent or supplementary angles in your picture? Logan? 46 and 44, like these two next to each other in angle A. Well, what would you get if you added those two together? No, you complementary. Complementary. But I like the way you're going with it, because won't this be a right angle that's 90 degrees? And then down here, don't you have another right angle? Yeah. And so if you take a look at these, you actually now have two congruent angles because they're both 90 degrees here, right? Now, if you take a look, line LA, visualize it's actually like a line that continues, right? And line TS, same thing, right? And then you have line AS kind of going through it. That means that line TA and TS are your two parallel lines, and line AS is your transversal. So that would make what angle relationship here? Same side interior, corresponding, or alternate interior? Same side interior, right. So which two lines would also be parallel if these two angles are congruent? Ashley? LA and TS. So we would say line LA is parallel to line, or I guess it's the same segments. We'll go with how they wrote it. So these segments would be parallel. And then which postulate or theorem justifies our answer? This would be the converse, how did I phrase this? Converse of the corresponding angles postulate. And remember, guys, you can always just write a statement. You can always say, if corresponding angles, or not corresponding, I'm sorry, I meant to write same side interior. My mistake. So you can always just say, if same side interior angles are supplementary, then lines are parallel. That would be okay as well. All right. We are crunched on time, but that's okay. Number 2, given the information, name the segments that are parallel, if any. So in this situation, if angle 1 was congruent to angle 8, this is actually a perfect time for our little letters that I told you about, because this picture isn't quite so wonky. You got to figure out what angle relationship is happening between angle 1 and angle 8, and therefore which lines would end up being parallel. What are you doing back there, Sydney? Oh, it's a zigzag. That's interesting that you notice it's a zigzag. See, I'm not crazy. There's a method to my madness. If you connect those corners, isn't that kind of like your Z shape, your zigzag? Then can you clearly see your alternate interior angles? It kind of helps you like remove some of that extra information that doesn't help you in the problem. So these would be alternate interior angles. Which two lines do you think would have to be parallel? Peyton? LP. No. That's a P. Yes, absolutely. PL. You said those, and I was like, wait, are we looking at the same thing? Line PL or segment PL and P or an AR. Good. Good. Okay, so same theory, guys. Take a look now at angle 5 and angle 3. Keep in mind, no is an option too. For these ones, if you kind of like look at those, first of all, aren't they both like below that slanted line? Yes, okay. But then isn't angle 5 formed by line PL? Isn't angle 3 formed by line LR? Are those even formed by the same like lines? Not really. Well, so what ends up happening here is that, this is just asking, sorry, I misread the problem. This is just asking if they were congruent, which lines would have to be parallel. So for this situation, this one, it doesn't really work for anything. It's kind of a weird picture, okay? This one would be no segments are parallel. That one would not work. That would not be an angle relationship that we have. I know we're gonna end in just a couple minutes. I will finish up the rest of these and post them, okay?